Nvidia, Microsoft, Amazon, Google, Meta. Right now, we are all watching these absolute titans of big tech pour staggering, just eye-watering amounts of money into artificial intelligence. I mean, it's a breathless race, right? Everyone is scrambling to get out in front of the next massive wave in tech.
We are literally talking about hundreds of billions of dollars. Just to put that into perspective for a second, that is more than the entire GDP of many countries, and it's flowing directly into data centers, new chips and software at lightning speed. And, naturally, when you see hundreds of billions of dollars flying around this quickly, it triggers a very specific thought. Is AI a bubble? It's the obvious question. It's what everyone is thinking. But here's the thing. Asking if AI is a bubble is actually, well, it's the entirely wrong question to ask. The technology is real, it's improving rapidly, and businesses are already using it. No, we need to be asking something else entirely.
Welcome to This Explainer. Today, we're going to look past the software and the hype to uncover the AI bubble's hidden problem. The real, deeply uncomfortable question we actually need to ask is this: can America physically build the AI economy fast enough to justify this massive financial investment? Because if it can't, the shockwaves are going to hit everything, from tech stocks right down to your monthly electricity bill. To answer that, here is our 6-step blueprint. We're covering 1, the trillion-dollar bet; 2, AI is not weightless; 3, the equipment bottleneck; 4, the mismatch of clocks; 5, the depreciation danger; and finally, 6, the real AI bubble.
So Section 1, the trillion-dollar bet. Moving money versus moving Earth. Because while a tech board can approve a $10 billion project in a single afternoon meeting, the electricity for it? Yeah, that doesn't just magically appear out of thin air. Section 2, AI is not weightless, the physical machine. We need to forget this digital magic trick illusion. AI is an enormous, heavily industrial, and incredibly power-hungry physical machine. Okay, let's dive into this. Getting one of these massive AI data centers online is not like bringing home a new refrigerator and simply plugging it into the wall. It requires an interconnection process. The utility has to carefully evaluate if the grid can safely handle this enormous new load without, blowing a fuse for the entire neighborhood. And if the utility says the grid needs upgrades to handle the AI data center, the timeline grinds to an absolute halt. Because building transmission infrastructure is painfully slow. You have to start with engineering, then you move to land acquisition, then comes the grueling regulatory approval, followed by environmental reviews, and only then, finally, construction. Every single step takes serious time. Section 3, the equipment bottleneck, supply chain reality. Because even if we somehow had unlimited power generation tomorrow, the AI boom still hits a brick wall in the physical supply chain. Just look at these bottlenecks. Gas turbines, transformers, transmission equipment, substation hardware, and crucially, the skilled workers actually needed to build all of this. These critical components weigh literal tons and require custom engineering. They are absolutely not sitting in an Amazon warehouse waiting for next-day delivery. They're manufactured by a very small handful of global companies. So when every tech giant suddenly wants to build dozens of data centers at once, the order books fill up instantly, and you are left waiting for years.
Section 4. The mismatch of clocks, infrastructure versus technology. Now, what's really interesting here is the hidden fault line running underneath this entire AI boom. We are dealing with two completely different timelines that are violently out of sync. This right here is the ultimate paradox. You've got the infrastructure clock, which relies on concrete and permits. It operates in decades. It is slow and it's physical. But then you have the technology clock, which operates in just months and years, driven by rapid software updates and silicon chips. The AI industry is sprinting at breakneck software speed, while our energy system is crawling at infrastructure speed. This mismatch of clocks, that is exactly what turns a technological miracle into a massive financial trap. Let's see how this builds into a serious threat. Section 5, the depreciation danger, the financial collision. What actually happens when these two totally mismatched clocks finally collide? Well, it's kind of like taking out a 30-year mortgage to buy a smartphone that's going to be completely useless in 3 years. You're stuck paying for this massive outer shell long after the brain inside is obsolete. The physical data center building, that lasts for decades. The heavy electrical equipment inside, decades. But the hyper-advanced AI processors that actually do the thinking, they're economically outdated in just a few short years. So there is an enormous financial risk here. A company could build all this massive capacity too early, only to find themselves stuck with extremely expensive infrastructure designed for processors that are already completely obsolete. Which brings us to the fascinating accounting reality of depreciation. This is the practice of spreading the cost of expensive equipment across the period a company expects it to remain economically useful. If a tech company incorrectly guesses that an AI server will be useful for 6 years instead of, say, 4, their short-term profits look artificially higher. But it's really just masking a deep, uncomfortable uncertainty about how long this technology is actually going to last before needing a total replacement. Section 6, the real AI bubble, when expectations outpace reality. You see, a bubble doesn't mean the technology is fake. Railroads and the internet were very real technologies, but they still caused massive bubbles because investors built physical capacity way faster than financial returns could justify. Read this quote with me. The faster AI becomes successful, the more electricity it requires. And this brilliantly illustrates the ultimate paradox we're facing, driven by that mismatch of clocks. Immense AI success directly creates immense infrastructure shortages. If the technology works exactly as well as they hope, the grid runs out of power, creating the exact bottleneck that sets the stage for a massive financial hangover. If that $700 billion bet on AI arrives 5 to 10 years late just because we couldn't build a power grid fast enough, the math entirely changes. A crash won't look like AI just disappearing overnight. Actually, it's going to look boring. It'll look like lower returns. It'll look like delayed data centers, because that massive physical debt and the relentless ticking clock of depreciation, they don't just magically disappear just because your construction timeline got stretched out by 5 years. It's going to look like higher electricity costs for you, because at the end of the day, the astronomical cost of upgrading the electrical grid to handle all this AI inevitably falls right onto everyday consumers. And it's going to look like canceled projects and massive write-downs. This is what a real AI crash actually looks like. It's investors waking up one morning and realizing that the spectacular future they already paid a heavy premium for is arriving much, much later than they were promised. So, the absolutely crucial takeaway is this. The AI boom isn't just one simple bet on smart machines. It's a highly precarious stack of interconnected bets. We are betting on AI demand, chip technology, data center construction, electricity supply, and future productivity all at once. And the riskiest bet of the whole shebang, the bet that all of these completely different industries will somehow hit their targets at precisely the perfect time? Which leaves us with this final vital question to think about. Will the finish line arrive before investors run out of patience? Remember, the digital future only arrives when the physical world is ready to plug it in. Thanks for joining me on this explainer, and keep your eyes on the infrastructure and that fundamental mismatch of clocks, because that is where the real story is hiding.